Okay, so today we are going to look into the reasoning as well. Okay, first thing to begin with, angle properties of circle. Obviously a circle must be given to you, am I right? If you have a given circle, okay, what are the things you can find out about a circle? We already know before. Obviously there must be a center, am I right? The center usually is defined by center usually, are you sure it's X? O, the center usually is O, and usually they may also give you the radius, am I right? If there's some form of dimensions that needs to be calculated. Okay, first thing, if I were to draw two lines, alright, if I were to draw two lines, okay, if the perpendicular distance, okay, from the center, the perpendicular distance from the center is equal. What can you tell me about those two lines which I draw initially? They must be equal. Okay, because the perpendicular distance away from the center is the same. So this line and this line is equal. Is there a special name to those two lines over there? Chord, thank you. Any line that cuts the circle into two parts, I didn't say two halves, any line that cuts the circle into two parts, this line is called a chord. But if the chord passes through the center, it has a special name, yes? Diameter, thank you. So far so good? Okay, moving on, some other definition. In a circle, okay, once you cut the circle into two parts by the chord itself, there is a bigger area here and a smaller area here, am I right? Okay, is there a name given to the bigger area and the smaller area? Anyone? Start with S. Segment, thank you. This is the what segment? What segment? This is smaller, so it must be the minor segment. So similarly, the one that is bigger must be the major segment. I just go through all the definition first. But that is when you use a chord to divide the circle into two parts. You also can cut the circle into two parts by having two radius. It's like a slice of pizza. Can you see that? So there is a smaller area as opposed to a bigger area. Now it's a different one. This is also minor, this is also major, but they are no longer called segment. Another S word. Anyone? Yes? Sector, thank you. This will be the minor sector. This will be the major sector. But usually during exams, they won't require you to really know what is segment, what is sector, but it's good to know because usually during exam, we will define the points and the vertices. Okay, this could be an AOC. So we'll tell you to find the area of the minor sector AOC. Okay? So far, any question with regards to this? I think these are all the very basic ones. I just summarized for you all only. Okay, now we're going to zoom in into the angle properties of circle. There are 5 key ones. Okay, and I want to take note of all these 5 key ones because we only need to use all these 5 key ones in order for us to solve all the questions. Okay, let's start with the very first one and the most popular one. I believe you have seen this. Does this look familiar? Yes. Okay, some of you will say arrowhead, this and that. Okay, but what is the property when you see this particular one? Okay. Angle at center. Okay, that's provided the center must be given here. That's good. Thank you. Angle at the center, subtended at the center must be twice the angle at the circumference. And we can write in short. You know circumference can be written this way. 0 with a dot in the middle to the power of CE. If you do not want, you can spell it out in full. Okay? So angle at center is twice the angle at the circumference. Meaning, if the angle here is x, what will be the angle subtended at the center? 2x. Okay, but this is the easiest form. I say again, this is the easiest form. What I want you to tell you is very importantly, it must come from the same 2 points subtended to the center. The same 2 points subtended at the circumference, and they must be pointing to the same direction. Meaning they are in the same sector. Okay? Or segment if you want to see. Can you see that I draw a red line over here? What do you notice about all the angles that we were looking at? They were all inside the major segment. Agree? They were all inside the major segment. Okay, this is the most obvious kind. I'm going to draw another 2 more, not so obvious to you one. Okay, this is another one. Same thing, the center must be given. Do they look the same? Okay, there are some intersections of the chords inside here. Doesn't really matter. Okay, what is important is, are they starting from the same 2 points? Is it connected to the center? It is. The same 2 points is also connected to the circumference. And more importantly, can you see that the angles that you're dealing with, again, if this is angle A, this must be angle 2A. Same reason, angle at center is twice the angle at the circumference. Can you see that now? Okay, I can tell you a lot of times, this question will come out more often than this one. Because this one is not so easy to see. So far so good? Okay, I'm going to give you the most difficult one. Okay, seemingly this one looks difficult, but it's really not so difficult. Okay, let me give you an idea. Let's say this angle here is actually, make it 110. Okay, I want to find this angle over here. Okay, a lot of times what students will do, what will they do? They may just say, oh, this angle is center, this angle is circumference, I will just divide accordingly. You are wrong. First thing, notice all the angles are all always pointing to the same direction. Am I right? So, if I want to make use of angle at center equal twice angle at circumference, this angle is pointing in this direction, but this angle is pointing downwards. Can I use the same property? I can't. So what do you think you need to do first? Thank you, Andy. You need to use 360 minus the 110, in this case is 250. Can you see that this angle is pointing downwards now? In the same direction of this? Okay, so there is a special name for angles more than 180. What is that name called? Reflex angle, thank you. Less than 90? Acute, 90 to 180? Obtuse angle. So take note of all this terminology. So in this case, after you find the reflex angle 250, then you apply angle at center is twice the angle at circumference, and this angle will be 250 divided by 2. This will give you a 125. Okay, these are the 3 classic examples under angle at center equals twice angle at circumference. But more importantly, I'm not going to ask you to memorize. You need to remember And I want you to, okay, the way I always teach this topic is, I want you to look out for a key feature. What do you think is very important if we need to apply this particular property? What must be given? Center, thank you. If in your diagram, the center of the circle is not given to you, there is no way this is going to be made use of. You all agree? That covers the first one. So far so good? Okay, this is the most popular one. Okay, the rest are slightly easier because this is the most complicated one. Okay, I can give you the second one immediately. Can anyone tell me what's the name of this property? Hazel, can you remember? No, I'm just summarizing what you did yesterday. Ashwa? Yes, it's 90 degree, correct. This is 90 degree, but what's the name of that property? Yes, Ryan? Again? Triangle in a segment? No. Can someone? Yes? Right angle triangle in semicircle, very lengthy, got shorter one, Yihao. You cannot find inside lah. I don't think you can find inside. Thank you. Angle in a semicircle. How do we know this is a semicircle? See, so what is the key feature here? The diameter. So long the diameter is given to you, alright? So long the diameter is given to you, the triangle formed with the diameter, provided the point is at the circumference, this will always be 90 degrees. Okay? And what is the name of the property again? Angle in semicircle. Angle in semicircle. Okay? So all the key names are in blue, the property. All the features are in green. But please don't give me the reason as center and diameter. These are just features for you to look at. Okay, another 3 more. The next one is very easy. This one come out, everyone can do one. Trust me. Have you ever seen something like this before? And usually, you will tell me, the angle over here and the angle over here is the same. Similarly, the angle here and the angle here is the same. Okay, this one is personally, I call this feature the butterfly. Does it look like the wing of a butterfly? Okay, so I call it a butterfly, but please don't give me the reason as the butterfly. I'll smack you in the face. Okay, this one is angle in the same segment. Alright, so long you look like a pair of the butterfly wings. Okay, what you can do is just tell yourself the 2 angles at the same pointing in the same direction are the same. The other 2 angles in the same direction will also be the same. And reason? Angle in the same segment. Okay, so far we have 3. And from here, I can go back to the very first one. Why do I say that? Take a look now. Can you tell me what is this angle over here? Yes, Sinta. YA. Angle in the... can you see? There's a butterfly wing over here now. This is A, this is A. So there are 2 reasons. One, angle in the same segment will tell you this angle and this angle are the same. Remember? The butterfly wings over here. Next, angle at center is twice the angle at circumference. That's the other one. That's why this one is an involvement from this one itself. Okay, so at the end of today, we need to remember 5 key properties. That's all. Very easy one. Okay, those are the ones in blue. Okay, moving on to the last 2. Have you all seen something like this? Okay? If it's a four-sided figure, what's the name of a four-sided figure? Quadrilateral. Thank you. But if the four corners of the quadrilateral actually touches the circumference, there is a special name. What is that special name? Do you all know? Cyclic quad. Thank you. If the four corners of the quadrilateral touches the circumference, it means that this is a cyclic quad, and the property is very important. This one is also very popular. The opposite angle will sum up to 180. What is meant by opposite angle? I'm going to show you now. A and B, are they opposite angle? What angle are they? Adjacent. If they are next to each other, they are called adjacent angle. So very good. So can you tell me which are the opposite angle? AC. Thank you. Okay, you need to skip the angle next to it. The opposite angle will sum up 180. Like he mentioned, there will be two pairs of opposite angles. Okay, so this is the property you can make use of, but more importantly, you must have a cyclic quad. And what is the name of this property? Anyone? Oh, you learned last year. Yeah. Angles in opposite segment. Thank you. Okay, this is angle in opposite segment. Please remember, the butterfly is angle in same segment. So far, any question? If not, we are going to move on to the last one. Okay, the very last one. Okay, this one is optional in E-Maths. So some teachers in other schools, they don't teach this, but I need to let you know it's not optional for A-Maths students. You need this for the last topic in A-Maths, which we are going to cover in July itself. Okay, this one needs a little bit of patience from you, because not so easy to see. Don't copy first. Yesterday you came across this word called tangent. What do you mean by the word tangent? Touch at one point, at the circumference of the circle. There are a few key properties when it comes to tangent, and the key word now is tangent. What can you tell me about tangent to a circle other than Hui Xuan actually tell us is, oh, touch at one point. What else? It's a straight line. What else? Come on, O level, we have students don't know how to answer, Any relationship with respect to the center? Again? Perpendicular to what? What is perpendicular to the tangent? You can say it's the diameter, or you can say it's the radius. Because there's this year, the question came out, I think just 2 or 3 years back, they asked, what is the reason this is 90 degrees? Some students don't know how to write. You just have to say tangent perpendicular to radius, you get your 1 mark. That's why reasoning is important. This is tangent perpendicular to radius. But like what you just mentioned, tangent perpendicular to a diameter, also nothing wrong. Okay, there's nothing wrong if you want to say tangent perpendicular to diameter. But this is not what I'm looking at in terms of the property. Okay? Now, just put down your pen for a while. The last property, what I really need you to know is angle in alternate segment. Have you heard this? I think if you have tried it. Okay, what do you mean by angle in alternate segment? Look here. First thing, in a circle, the tangent line must be given. Next thing, from the point, the one point which the tangent touches the circle, there must be an inscribed circle. Actually, what is meant by inscribed? You all have seen this word called inscribed, right? Have you all seen this word? What do you mean by inscribed? The triangle is inscribed inside the circle. Make a good guess. Yes, Jia Kai? It's inside the circle. So like that is inside the circle? Now inside ma? The triangle is inside the circle.
Similar to the triangle in the semicircle.
Similar to triangle in semicircle. Okay, Jason, a little bit more. Inscribed inside the circle, yes, I agree with both of them. It's inside the circle. Not enough. What else? All the points must touch the circumference. So I can draw any inscribed triangle inside the circle. And now don't blink, I'm going to tell you how to identify angle in a alternate segment. Okay? The angle subtended by the tangent and the triangle. Can you see this? The angle subtended by the tangent and the triangle over here. Okay, let's call this angle X. If this is angle X, what I need to do is just walk along the same path. Skip the first angle, the second angle will be equal. And why are these two angles equal? Angle in alternate segment. I'm not going to do the proof because it's quite lengthy. You just need to know it. Similarly, is that the only angle subtended by the tangent as well as the inscribed triangle? You realize the other side also has another one? Let's define the other side then. Let's call this Y. Same thing. I'm going to walk along the same path. Are you using the first angle? No. Skip the first one, the second angle, and there you have it. All 5 properties are listed over here. Okay, all 5 properties are listed over here. So if you need some time to pen it down, please do so, because I realize inside your tangent series they don't really have a summary for you. So it'd be good to put it on a piece of paper. But last but not least, I want to do something else. This is a very useful property. In any circle given to you, if I draw a triangle from the center of the circle, what can you tell me about this triangle? Why is it isosceles? Thank you. This triangle is formed by the radius of the circle. And this is an isosceles triangle. And I believe if you know the property of isosceles triangle, which I told you previously when we did the circles in A math, what did I say about the triangle, isosceles triangle? Isosceles triangle, I said something. Good to use one. No? Anyone? I can cut the triangle into half. And this will be the midpoint. And not only does it cut into half, it will be a perpendicular bisector. Remember I said that before? So this half and this half will be the same. This will be the midpoint. Okay? This is true for isosceles triangle. And how do we get isosceles triangle? The triangle is formed by the radius of the circle itself. Okay, and we are done with it. So if you need some time to copy down, I'm going to give you the next 3 to 4 minutes. Then we're going to tackle some questions from the tangent series as well as my exam questions. And how I tackle the question? Very simple. Don't fuss. Look for the key feature first. Once you look for the key feature you can identify, straight away do it inside the circle before you solve the question. That is what I'm going to tell you.